Hello geometry students, and welcome back to another video lesson as we continue our chapter on 3D shapes. Now we're going to get into volume. We're going to talk about volume, which I hope is a little bit more straightforward than some of our surface area and lateral area, but I think you're familiar with some of these concepts for volume. Now, we have to go back and think about and remember, what is a prism? Again, a prism. A couple key characteristics. Each prism will have two bases, sometimes squares, rectangles, triangles, pentagons, things like that. So it will have two bases. It will also have lateral faces that go around them. And we typically have a height, which is the distance between your bases. How far apart are the bases of a specific object, right? So if you think of even a cylinder, for example, let's just try and quickly see. Well, let me draw a cylinder. Oh, that's because I have to change the color. So if we think about a cylinder that maybe looks something like that, and we connect them, right? I've got a circle on top and a circle on the bottom. Those are my bases. The lateral faces around. The height is how far apart are your bases. And that's important, knowing that height, because we have a formula for volume. Now, first of all, volume is going to be units cubed, because it's trying to think of, how much water we could put into a 3D object, or how much we could fill it up, right? So volume equals capital B times H. But these B and this H stand for something unique. Capital B is the area of one of the bases, right? Because the bases are the same, we have to find the area of one of those bases, and then we're going to multiply that area by the height between your two bases. Volume equals base of the area of the base times the height. And that's why we did a little bit of review and exploration yesterday on the area of bases, because we just need to know how to calculate the area of specific bases. Okay, so this is the formula that we're going to use a lot, knowing again capital B stands for area of a base. Example number 1, we're going to find the volume of this prism below. I'm going to show you that the base in this one, the base is this rectangle 7 by 8, which means area here is 7 by 8, or 56 square inches. So volume here is going to be capital B times H. We just found capital B to equate to 56. How far apart are these front and this back base? 12 inches. So we can calculate 56 times 12, or 672 cubic inches. So we start by finding the area of the base. In this term, it was just a rectangle, multiplying it by the height between those two bases. Now, the next one is a triangular prism. Triangular prism, meaning the base, all right, the base is a triangle. Show me the right angles here, and that this is 6 and this is 10. We've got one small problem for a triangle. The base and the height must meet at a right angle. So this is the height of the triangle right here, and I don't know it. Well, when we have two sides to a triangle and we're missing a third, we can use Pythagorean theorem. X squared plus 6 squared. How about 6 squared equals 10 squared? Or x squared plus 36 equals 100. Subtract that 36 from both sides. And x squared would have to equal 64, when we take the square root of both sides, x will equal 8. So that side of the triangle over here is going to equal 8. And again, we need that as the height because the base and the height in triangles, in trapezoids and things like that, they have to meet at a right angle. So our capital B, the area of the base, is 1/2 times my base, which is 6, times my height, which we just said was 8. Half of 6 is 3. 3 times 8 is 24. So the capital B in my volume formula, capital B times H, is 24 times the height between the two bases. My front is here, my back is there. The height between them is 25. 25 times 24 should be 600. Our volume is going to equal 600 cubic centimeters. So again, we might have to use some of our skills and strategies from earlier to help us think about how to find the area of a base. Case in point, our last example. Find the volume of the prism below. Well, hopefully you notice that the shape is really a pentagonal prism with this pentagon out front. Whoop, and a whoop. And they say a right angle with a 3, a 4, a 5, a 5, and a 5, right? That 5 can come right here as well. So how might we find the area of that pentagon? Why don't you take a moment and see if you can't find the area of the pentagon? Well, I think what I would do is try to separate it into two shapes. I'm going to separate it right here, a triangle on top, rectangle, square, really, on the bottom. 5 by 5 on the bottom would give me an area of 25 down here. The area for this triangle is 1/2 times 3 times 4. 3 times 4 is 12. Half of 12 is 6. Add them together, and our capital B is going to equal 31. The area of that front base is 31. So volume equals capital B times H. Capital B is 31. How far apart are the front and the back? That's this number here, which is 8. And 31 times 8 is 248 units cubed, cubic units. So again, hopefully you're just seeing we're trying to find the area of a base and multiply by the height between your two bases. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.